get your last test review. Tuesday will be your last test. Then we will proceed in watching Wister, which should line up perfectly because I think you kids have a half day on the last day. So we should be able to squeeze it in within the time frame. All right, so this last section, as we talked about yesterday, is talking about trends. And yesterday we talked about atomic radius as well as ionic or ion radius and those trends. Today we've got two more trends. Okay, we've got trends involving energy and energy to remove electrons and energy to attract electrons. Okay, I made a change in the notes, and I'll point it out to you because there was an error in some of the wording. So I'll get to that here in just a second. So the first trend that we're talking about is ionization energy. Okay, we talked about what an ion is. It's an atom that has become positively or negatively charged, depending on if it's gained or lost electrons. Ionization energy is the energy that is required to remove an electron from a gaseous atom. And so we need to have this energy in order to overcome the attraction between the positively charged nucleus and the negatively charged electrons. Okay, it's like trying to pull magnets away from each other. You have to have some energy input to separate them. And when this happens, when you have electrons that are being removed, you then form a positive ion. So in normal everyday terms, it's a measure of how strong an atom can hold on to those valence electrons. If an atom has low ionization energy, it means it's going to be rather easy for those atoms to lose their valence electrons. And in this case, atoms that have a low ionization energy, you're going to have the formation of a positive ion. If an atom has high ionization energies, that means it's got a super strong hold on those valence electrons. It takes a high level of energy to separate them. Now, the statement below here on B1 is what you need to change. Okay, I believe it says less likely. You need to cross out less. It's likely to form negative ions. When an atom has high ionization energies, it does not want to give them away. So those particular atoms will tend to form negative ions because they'd rather attract electrons than to give them away. And so there are various levels of ionization energy, and they are all named after the number of the electron that is being removed. So if you think about electrons, the valence electrons being removed one at a time, you have the first ionization energy, meaning that's the energy required to remove the first electron. The second ionization energy, as you probably guessed it by now, it's the energy required to remove the second valence electrons. Now, each time that you remove an electron, you have to input more energy to remove the next one. That's because as you are removing electrons, those protons in the nucleus begin to have a much stronger pull on those valence electrons. So that's why you have to increase your energy. It's like adding more strength to magnets. Okay, each time you have to use more energy to remove them or separate them. So in the periodic table, we also have trends for ionization energy. So within a period, so the horizontal portion or the row of the periodic table, you're going to have an increase in first ionization energy going from left to right. Again, left to right, you're going to have an increase in ionization energy. And that's because as you go across the periodic table, that number of what's called nuclear charge, that number of protons that you have in the nucleus is also increasing. And as we talked about yesterday, those core electrons are not increasing. So you keep adding more and more protons to the nucleus, that's going to give them the ability to constrict or have a stronger hold on those valence electrons. As we look in the groups or the vertical aspect, the first ionization energy is actually going to decrease as we go down a group. And that's because as we go from top to bottom, the size of our atoms is going to increase. So they are a farther distance away from the nucleus, which makes them easier to pluck away from the atom. So typically requires less energy since they are farther away from the attractant force of the protons. And I believe we've mentioned this before, but the octet rule, which states that the atoms tend to gain, lose, or share electrons in order to acquire a full set of 8 valence electrons. Those elements that have the 8 valence electrons are typically the noble gases, with the exception of helium. So if you think about it, a lot of the other atoms are trying to be just like noble gases in terms of their number of valence electrons. Because when you have 8 valence electrons, you become more stable. Okay? The octet rule is useful for predicting what types of ions an element is likely to form. The elements are located on the right-hand side of the periodic table, so the nonmetals, they like to gain electrons so that they can acquire this noble gas configuration. And so when you gain electrons, you form negative ions. Elements on the left side of the periodic table, so we're talking metals, they would rather get rid of their electrons. And so you have fewer electrons in the atom itself, you have more protons, therefore you're going to have a positive ion being formed. Again, metals tend to form positive ions, nonmetals tend to form negative ions. Did you have an uh-oh, Ashley? I did. A soda. So, last topic, trend that we're going to talk about is electronegativity. Okay. Now, this is essentially the opposite of ionization energy. Electronegativity is going to be a measure or an indication of an atom's relative ability to attract electrons. And so, if you are a nonmetal, you're going to have a pretty large measure of electronegativity. And we rank the elements based on their electronegativity using what's called the Pauling scale. Okay, this scale is based off of a value of 3.98 to 0. The reason why it goes that way, what I mean by that is it doesn't go from 0 to 3.98, is because electronegativity values are typically negative. So if you have an electronegativity value of 0, you're going to be the least electronegative. The noble gases are considered to have basically a 0 electronegativity value. Fluorine is the greatest, so it's going to have a strong ability to attract electrons. Francium is going to have the smallest besides the noble gases. So the atom with the greater electronegativity is going to more strongly attract the bond's electrons. So when we have situations like this, we can help determine the types of bonds between atoms. Now, we don't need to worry ourselves about this, but we start getting into polar and non-polar type bonding situations. But using this scale, we can help us determine that, because then it helps determine the overall characteristics of chemical bonds. And last but not least, the trend associated with electronegativity. So within a period, as we go left to right, the electronegativity increases. Because as we move further and further to the right side where the nonmetals are, we have a greater ability to attract electrons to themselves. Vertically speaking, in a group, electronegativity is going to decrease as we go down a group. The lowest electronegative elements are found in the lower left of the periodic table, and the highest electronegative elements are going to be found in the upper right. So, as I mentioned, noble gases, they don't like to form compounds. They don't like to bond with anybody. There are some exceptions. Like xenon, for instance, it has been shown to form compounds, but that's due to its relative size. But they like to just be chill and hang out and not really do anything, so their electronegativity is. With that, ladies and gentlemen, we have just finished the last set of notes for the year. Don't forget, tomorrow is a homework check, so you want to make sure that you have all of your notes for Section 3 written out. And again, Friday, you will receive your test review.